So we face an unfortunate fact. So we're in the midst of the sixth mass extinction. And despite the vast array of technology we have at our disposal, we really can't do anything to prevent all the endangered species from going extinct in the animal kingdom. But what if we can buy some time? So my name's Joe Kangas, and my research is in cryopreservation. So we have one main goal, and that's to preserve animal species at the embryonic stage, because at this point, they're so small and malleable that we can actually store them and cryopreserve them. But how do we go about doing this? You can't simply put an embryo in the freezer because ice will form and that'll rip the cell apart. Ice is incredibly damaging. But what if we can prevent ice from forming in the first place? It turns out that if we infuse special chemicals called cryoprotectants and then plunge these embryos into liquid nitrogen, they cool down so fast that water doesn't have time to reorient itself and form ice, transforming it into this new type of substance. It's a different phase of matter called glass. In this state, there's no molecular motion at all. Chemical reactions cease. It's effectively like the whole thing is frozen in time, because it really is. And at this point, storage times are infinite, so it provides like the best opportunity for preservation. So once they're in this state, you can hold them indefinitely, but you have to get them warmed up eventually. So what we do, we have to warm them really fast because ice tends to form really quickly on rewarming. So we infuse them with nanoparticles as well as cryoprotectants and then shoot them with a laser. And this heats them up at millions of degrees per minute and again outpaces the reformation of ice. And we have actually validated this on several different species. We're able to cryopreserve coral and rewarm them. They're one of the most endangered species that we know of in the ocean. We also did for zebrafish embryos, which are a model organism for all types of genetic research and aquatic organisms. So the idea would be to extend this research into basically the rest of the animal kingdom. So we would like to take all the animal species that are endangered, and we could feasibly do this and cryopreserve their embryos and put them in some sort of banking facility. So this would be like an animal biodiversity bank, similar to the Svalbard Plant Global Biodiversity Bank, which houses much of the world's plant and agricultural seeds in Norway. So the main technological challenges for this include finding the right cryoprotectant and finding a way to engineer cooling and warming rates so that they're really rapid but also really uniform. And by using this technology, we can help buy some time to preserve the endangered species that we have right now so that once we fix all the damage we've done to our environment, we can bring them back and reintroduce them. Thank you.